You now know how to control both the distance and straightness of your robot's movements using the shaft encoders. These capabilities, along with even more powerful ones, are available with the Integrated Encoder modules, sometimes called Integrated Motor Encoders, or IMEs. In this lesson, you will learn how the integrated encoders work, then open and explore a program that uses them. You will need to have the integrated encoders connected to your robot before following along. Like the shaft encoders, the integrated encoders can control the distance your robot moves by measuring the rotation of the motors. Unlike the shaft encoders, the integrated encoders connect, or integrate, directly into the VEX 2-wire motors. Because of this, the resolution of the encoders is dependent on the motor's internal gearbox, which is set for high torque by default, but can also be set for either high speed or turbo speed. With the shaft encoders, one full rotation equals 360 counts. With the integrated encoders, one full rotation equals 627 counts, unless your motors are configured in high speed or turbo speed. Another key difference between the shaft encoders and integrated encoders is how they connect to the cortex. While each shaft encoder takes up 2 digital sensor ports, the integrated encoders connect using the I2C port on the cortex. I2C is short for Inter-Integrated Circuit and is a method of communicating data between smart sensors and the robot. The cortex only has a single I2C port, but that does not mean that only one integrated encoder can be connected. Up to 8 integrated encoders can be connected in a daisy chain, where encoder 1 connects to the cortex, encoder 2 connects to encoder 1, encoder 3 connects to encoder 2, and so on. Let's get started. In Robot C, go to File, Open Sample Program, Open Integrated Encoders, and select Forward for Distance with IMEs. This program follows the same pattern as the shaft encoder's forward for distance code, but with some new commands. The pragma statements at the top still configure Robot C to work with the encoders connected to your robot. Open the Motors and Sensors Setup menu and click on the Motors tab, which contains all of the configuration settings. The right and left motors on ports 2 and 3 are set up as the 2-wire VEX 393 motors. Under Encoder port, you can see that the right motor is configured with I2C1, the integrated encoder directly connected to the I2C port on the cortex, and that the left motor is configured with I2C2, the second integrated encoder along the chain. Next, these two reset motor encoder commands set the integrated encoders to start counting at 0. Notice that the motor names right motor and left motor are used instead of another sensor, now that the encoders are integrated into the motors. The encoders should be set to 0 every time you want to use them to control the distance the robot travels. Then we have the while loop, which is checking the value of the right integrated encoder using the get motor encoder command. Again, the name of the actual motor is used inside of the command. The while loop will repeat our basic movement commands while the value of the right integrated encoder is less than 1800, a little less than 3 rotations of the motor, if configured in high torque mode. Let's try it out. Make sure your robot is turned on and connected. Compile and download the program, and run it. The robot waits for 2 seconds, moves forward, and stops. In this lesson, you learned how the integrated encoders compare to the shaft encoders, and ran an existing sample program that used them to control the robot's forward distance. Move on to the next lesson to improve the forward movement by enabling PID speed control.